Hello programmers. Today I want to show you, I'm going to call this tutorial 5.5. This is going to be the last of the tutorials teaching you how to write libraries in Coder's Basilisk. What I'm going to be demonstrating here today is how to do conditional compilation. Basically, in C, you have this system where you do, like, for instance, if def underscore win32 underscore, right? And then you have some code, right? So like, and then else, and if, and then some other code, right? And this gets compiled into this is what gets compiled if you're on Windows, and this is what gets compiled if you're not on Windows. So today I'm going to show you how to do that using Coder's Basilisk. Right, and we're going to use some meta-programming to do that. And basically what I have here is I just have this little bit here, and I also have two different ways of doing conditional compilation inside the library. Right, this is a modification of the multi-file project example from, was it the last tutorial? Yeah, from the last tutorial, multi-file project. So this is a modification of the previous tutorial to add system-specific behavior. All right, so we have we only have two targets defined. We have Windows and we have not Windows. Obviously, you could have as many as you want defined, right? And I'm going to show you how to set this up. Right, this is where this is going to set up. But first, I have to explain how it works. I'm going to first talk about how to do it using Coder's Basilisk, and then I'm going to talk about how you can still use the C way of doing it if you really want to. So here we have defined two macros, basically, and one of them is compile if Windows, and the other one is compile if not Windows. And what these do is basically they either allow this code into the compilation unit or not, depending if it is Windows or not. And this one will only compile into the unit if it's not Windows, and this one will only compile into the unit if it is Windows. And I can just show you guys here that right now it is configured for targ not Windows. So let's build it and then run it. I've already run it a couple times here. Let's run the program, just feeding it some integers. What are you running? See, it prints out this line here, right? Now let's change this here to a // and this. Let's say we're compiling for Windows now. Now, obviously, we're not actually compiling for Windows. This is Windows subsystem for Linux. So this right here, we're going to talk about that later, but this is the important thing to look at here, and this one here, right? In main.cbas, get a better OS is what should print out if this is set to targ underscore Windows, all right? And again, we're going to talk about how this is implemented. This is implemented down here and up here. We're going to talk about how that works. You might be able to deduce how this works just from looking at it, but we're going to talk about it. Let's briefly talk about, though, you can also use the C way of doing things, right? You can see here in main.cbas we call cool function, and we have cool function 2 here, right? Cool function and cool function 2 demonstrate the two different ways of doing conditional compilation. You could do conditional compilation either through through the C way of doing things or through the Coder's Basilisk way of doing things. We're going to talk about the Coder's Basilisk way of doing things first, because we talked about it here in main. So here is cool function 2. This is compile if Windows. This is compile if not Windows. And right now we are configured to be Windows, right? So that should be printing -53 here. Let's quickly change targ to be not Windows. Rebuild it. So this will change to be 312, right? 312, yes. Okay, see, this number here after cool function 2's response is now 312, right? So that's this return value is now that, right? And this is being printed out right here, in case you were wondering, right? Now let's look at how cool function 1 does this, right? The first cool function, right? There's no actual 1 in the name. It's the first one I wrote. Anyway, so as you can see here, we have ASM statements, and ASM basically says directly write this string to the output file. And then we have an if def here, if def win32, else, and if, right? And if we go to lib.c, you can see here that our if-defs got literally inserted right here, right? If-def win32, right? And then we have Windows behavior and cool function, non-Windows behavior and cool function, right? So you can see here that we are using traditional C-style conditional compilation as an example right here, right? Now, I do believe you should use the Coder's Basilisk style of doing things, right? And by the way, there are other ways that you can do conditional compilation to Coder's Basilisk, right? I was actually thinking of earlier, you could actually have a prototype function, but you know, whatever. It's not important. Anyway, so point is, this is two different schemes for doing conditional compilation in Coder's Basilisk. This one is just using C's conditional compilation, and this one is using Coder's Basilisk, right? Now, you might look at this, and you might think this is kind of ugly, but I will explain in a little bit. In fact, I'll show you how to make this pretty, right? We're going to make this pretty after I explain it. So the first thing you need to understand is this right here. If we tab over to this, this is the file being included here, which if we go to here, this doesn't have any includes in it, and if we go to the user mode standard library, this includes meta, right? And if we go to meta, this is the standard meta library, right? It's including the standard meta stuff into the compilation unit, and that's where we get this thing right here, right? This is how we get this from standard meta, from the meta programming library. So I needed to mention where that came from. Where's target.hpass? Aha, here's target.hpass. Sorry that I'm jumping around so much. I know that might be kind of confusing. You can just look at the code. It should be linked in the description if you're confused. So anyway, we include 2C native user, which includes the standard meta programming library. All right, I needed to mention that because that's where this stuff comes from. And then what we do is we create two worksheets. Now, worksheets are basically the equivalent in Coder's Basilisk of a macro with arguments in C. Except there are extra things that worksheets can do that C macros cannot. And we'll talk about that in future tutorials. That basically you can write compile time code inside of this inside of a third argument here, right? But that's not here or there, right? What I've defined here is I've defined two worksheets. This one here, which just pastes in its input if it takes its input and then regurgitates it back out, and this one does not, right? It just emits a semicolon. Now, I believe this will actually not work if I don't have a semicolon. That's my recollection. Yeah, worksheet code section was empty, right? So it does not work. So you must include something in the worksheet body. So we just put a semicolon there. You could also, for instance, have a dummy parse hook, right? You could define a part. If you absolutely did not want to have anything here, no tokens, you could also do a function codegen parse hook dummy do nothing. You need to do at dummy, and this would also work, right? Because what this is going to do is it's going to call this parse hook, and then there's going to be no token output, and there's going to be literally 0 tokens inserted, right? And this will work exactly the same. But I just wanted to illustrate that, right? So this is another way you could do that. I think a semicolon is just briefer, right? But if you absolutely have to have, if you can't have a semicolon there, for instance, if you're in the middle of an expression, if you need to do conditional compilation in an expression, you can have a dummy function like that. We're actually going to put that inside of a comment here. At dummy. Another way of doing it. In case you want to do conditional compilation inside an expression. So anyway, we define these two worksheets: compile true, compile false. Compile false says that instead of emitting the stuff we take in, we emit a semicolon. And compile true says that we take what we take in and we re-emit it, right? Now what we would do with this is that we then define two parse hooks down here. These two parse hooks are for each of our targets. Compile if Windows and compile if not Windows. And again, obviously, if you wanted to define more than two targets, you could define more than two functions. In fact, you know what, let's do that during this tutorial, right? I'm going to extend this to add new targets, right? Let's do targ haiku 2, targ, what's another popular operating system? Mac OS 3, Android 4. Right, so we're going to have not Windows, Windows, Haiku, Mac OS, Android, right? I guess we'll actually we'll remove the not Windows target, right? Haiku, Android. We'll say, oh yeah, and we'll have actually we'll have targ Linux as 0. Targ Linux, right? Okay, so and then we just reproduce this for we have Linux and Windows. Okay, so let's paste them. Let's do them in order. Linux, Windows, Haiku. We need Haiku. Let's do Haiku. Haiku. Now let's duplicate this. I might make a mistake, by the way, while I'm writing this, right? In which case you're going to learn. You're going to learn Mac OS. Haiku. Mac OS. I think that's all 4. 1, 2, 3, 4, 5. Oh, and then there's Android. We want to undefine them just in case, you know. And then Mac OS, Android. Okay, so now we've defined Linux, Windows, Haiku, 3, 4, 5. 5 targets? 1, 2, 3, 4, 5. Yeah, okay. And this one needs to be Android. Linux, Windows, Haiku, macOS, Android. Right, okay. Okay, that's perfect. Okay. And we have this little thing here, right, that we can choose what target we want to compile for. And let me show you real quick how you make it, how you make this pretty. Okay, so what you do is you just take this, so this is something that even your boss can figure out, right? Uncomment the one you want, right? So this is config.hbas, and then it goes here, right? This is the contents of config.hbas. Now let's modify our code to handle more than not Windows and Windows. Linux, I believe that's what we called it. It's vsplit targ.hbas. Let's see what we called it. Compile if Linux. Linux behavior in cool function 2. Then we have Windows. Let's put that second so that they're in order. Compile if Haiku. We're gonna do compile if Haiku. Compile if Haiku. Haiku behavior. Type a number here. Then Mac OS. Hold on, what do we do? Sometimes I press keys that I don't mean to. And we're going to type maybe 10,000 or 10,000. 10,000. There's 3 here and 1 there, so that's 4, so that's 10,000. Okay. Android. Again, if you see a typo, guys, I'm going to find out about it. Don't worry. Compile if Android. And then we're going to do Android behavior. We're gonna return 13,000, negative 13, no, positive 13,000 if Android, right? And then let's go to main.cbas, compile if not Windows. Compile if Linux, cool OS. No, it's compile if Haiku, cooler OS. Compile, let's do Mac. What did I call it? What did I call it? Mac OS. Ew, an Apple product. Yuck. Because Mac sucks. Sorry, guys. And Android. Let's quickly do that. Main.cbas. Android. Like data from Star Trek. And let's see what programming mistakes I made. Oh, did I actually get it first try? Okay. Non-Windows behavior and cool function. And then, oh, wait a minute. I messed something up. Okay. What did I miss? Oh. It was not equals there. Okay, that was the mistake I made. Linux behavior and cool function 2. Cool OS, right? And it returns 312. Cool function 2 returns 312. Okay. Let's get back on track, right? Let's vsplit main.cbas. Okay. So here we say length is, and then we say the length of this vector. I think that's probably correctly calculated. I'm not going to do the math. Non-Windows behavior and cool function, right? So we see here that cool function here is still just using C conditional compilation, if diff win32 else and if. Then what is this 37 here? This is the return value from cool function, which is what happens if you have non-Windows behavior. That's right. Then cool function 2, and we get Linux behavior, which returns 312. Yes. Then we print negative 129 for some reason. Wait, what? Oh, that's because we print my cool variable. Yeah, I see. And then we say cool OS, which because we're doing Linux, right? Now let's say we want to switch targets to Haiku, right? So we have our targ.hbas and our config.hbas. Now remember, this is the only thing your boss is going to see, right? This is what your boss who doesn't know how to program is going to see. Instead of compiling for Linux, let's compile for Mac. Let's rebuild the project. Ew, an Apple product. And wait, what? Why is it compiling the Android code? Okay, hold on. We messed something up. I made a mistake in my haste. Okay, here. Mac OS and Android. Okay, so that's working. We forgot this. We did Mac OS twice, right? Okay, so pardon. You saw that probably, right? Ew, an Apple product. Yuck. Right, now let's try compiling. Okay, hold on. Let's check this. Mac behavior and cool function 2, negative 10,000, negative 129. Let's see about this, right? Okay, well, cool function 1 and my cool variable we don't care about. Let's scroll here. Negative 10,000. Is that the return value for if Mac OS? Yes, right here. Okay, ew, an Apple product. Okay, now let's configure it for Haiku. Now we're going to build for quote-unquote Haiku, right? Just imagine for a moment that we were compiling for Haiku. Haiku behavior and cool function 2. Cooler OS. Okay, now we're going to build for Android. Android, like data from Star Trek. And 13,000, that is the thing for, yes, compile if Android returns 13,000. Yes. You know, as you recall, guys, after we print out, after this returns, and then that gets printed out. Yeah. So anyway, this is an example of how you do compilation for multiple compilation targets in Coder's Basilisk, and how you can make it pretty, and how it works, right? So I'm going to briefly talk to you a little bit more here for future reference about the more advanced things of what's happening here. Okay, you can basically just copy paste this template for conditional compilation to all of your projects in order to do multi-target compilation. And this system actually should work better for you than C. Because okay, hold on. Just wanted to add that. I want to add this anyway. So this is another way of doing it. You can just copy paste this file here into your projects and then modify it to your liking, add new targets. Remember to undefine so that you don't have these defines lingering in your program. And you can add new functions here like this, right? And you could template this, by the way, right? You could template this using worksheets, but we're going to talk about that in a future episode. So basically, the in-depth explanation of what's happening here is that anytime that you have at something, right? Anytime you have at whatever, right? Like this worksheet, right? There is a function somewhere called parsehook_worksheet. And that function is being called right here, right? At parse time, right here. And then it is, it's basically consuming these tokens, right? And we're going to talk about how that's implemented later. In fact, I'll probably actually show you the source code for how this is written. It's quite complex, but you know, it's I can show you how this is implemented. There's a function here called this, right? So what we're doing here, right, is we define these two worksheets, right, which will define these things that you can invoke like this: at con compile true and con compile false, right? So you could do this, right, and it would work, right? And what we do down here is we define some parse hooks, compile if Linux, compile if Windows, that tail call con compile true or con compile false, right? And tail just means it jumps into that function, which is perfectly valid, right? We could literally call it and then return, but tail calls are more efficient. It's why we have tail calls in this language, for efficiency's sake, you know. And if targ ID is targ haiku, con compile true, else jump to false, right? And you know, we have this for all of these different cases for these 5 targets. 1, 2, 3, 4, 5, right? You could add more or have fewer or however many you want. And that's how it works, right? So that's why this works. That's why you can do at compile if Linux. That's why that's how all of this works. Again, if you found my explanation poor, if you didn't like how I explained things, by the way, guys, let me just review for you. / let's clean up. These are let's go through each file of the project just for review. This is main.cbass, which has our main program in it, right? This is a library we wrote in a cbass file. This is the header file for the library, right, which goes with lib.cbass. And then here's targ.hbass right here, which says here how to build for multiple targets, right? And we're actually using 2C native user right here. I guess in practicality, if you were compiling for multiple targets, you probably wouldn't use my native user library, but whatever, right? You could replace this with whatever you want. Just make sure you include meta, right? This is non-negotiable, right? You need to include meta. This will still work, by the way. Yeah, right. And we have it configured for Android right now. Right, so and targ.hbas right here. This defines how to conditionally compile code for different targets. And then config.hbas right here gets included right here in the middle of this statement right here. Right, we have a statement defining a global codegen variable, and we just pound include config.hbas, and this defines target CG target ID, which is a by the way, CG underscore. This is a convention. This I usually name things involved with compile time code, and I started with CG or CG underscore. This is just a convention. And we include this. If we go here, you just uncomment the line you want, right? Targ Linux, targ Windows, targ macOS, targ Haiku. And these are just defines from here, right? And that's how you do this, right? Let's just make sure I didn't break anything while I was showing you the code. Anyway, so that's how you do that, right? And we use these things, right? These parse hooks in order to parse hook underscore functions, right? We remember how these work, right? Right? This right here is going to call this, right? And actually, we can. So basically, and what this is going to do is, because this jumps to cond true or cond false, is it's going to consume an argument list, which is just this, right? And it's going to either duplicate it or just output a semicolon. So that's how that works, right? You'll be able to understand this better in future tutorials. Just try to look, if you want to do conditional compilation in Coder's Basilisk, you can just duplicate this template, extend it, remove things, whatever, to your heart's content, and it should work just fine. So I ask you to study this carefully, and write comments if you're confused, and that's about it. Again, I'm sorry that I'm perhaps not the best at explaining things, but that's how you do it, right? I'm hoping that this is simple enough that you can just sort of understand how this is working, right? I hope you guys enjoyed. Thanks for watching.